Welcome to my laboratory again. Okay, this is more impossible tricks with function generators. Sorry about the light. Let me turn the lights down a little bit so that you can see what's going on here. First of all, you can see, of course, that the LED is turning on and there's about, well, I don't know, 36 milliamps of current going through there when it's on, something like that. And that's coming from the function generator. Its output right here. It's going over to the oscilloscope, and what's being shown there is this trace going up and down is the signal from the function generator. Okay, the other dot just going across the middle is just a marker, so that you know where the middle is. It's not doing anything except indicating where the middle of that trace is. Okay, so the up and down trace there is the sine wave, slow sine wave coming from the function generator, and I think you can see that it has to go a little bit positive above the tracer dot before the blue LED comes on, and then there's current flow, right? Okay, now we're looking at that at 5 volts per division. There's no attenuation. So 5 volts per division. So we're going up to about 3 volts to turn the LED on, and we're going down to about -6 volts. Now if the LED wasn't there, you wouldn't see that voltage drop at the top, and it would be a symmetrical plus or minus about 6 volts, right? But since we've got the LED there, that's using some voltage, some power, so you get a little bit of voltage drop, right? And I can prove that to you just by unplugging the LED. Now you can see that there's a nice symmetrical plus or minus 6 volts on that sine wave, right? Okay, now I'm going to hook the LED back in. Maggie wants to come in and play, but I'm busy. Okay, so let me get a little bit of the light up there. Alright, so can you see what's going on so far? Don't pay any attention to this. So we've got positive and negative sine wave of 6 volts, and it's lighting the LED when it goes over about +3 volts and showing current flowing on the milliammeter, right? What's this? It's a 9-volt battery, and its leads are just dangling right now. It's not hooked up to anything, but it will be in a moment. Okay, so now what I'm going to do is I'm going to use the function generator's offset control to offset that signal down until the LED no longer lights. Okay, so you can see that I've offset that sine wave negatively, so now it's staying completely negative, and of course the LED isn't lighting, right? Because the function generator is putting out a sine wave, but that whole sine wave has been shifted downwards with the offset control so that the voltage now never goes positive enough to light the LED, right? Right. Now what I'm going to do is take the 9-volt battery and put it in series with the function generator. Okay, if I can do this one-handed. Let's see here. Alright, so series means the red of the battery goes to the black of the function generator somehow, right? You try this with one hand, and the black of the battery goes over to the meter. Alright, now you see there? So the function generator is still putting out its signal, but I've hooked up a battery in series with the function generator. Alright? So what the LED is seeing is the summed voltage of what the function generator is putting out and what the battery is putting out, and the current is flowing through the function generator, through the battery, and through the meter, and through the LED. Alright? So there's a battery in strict series with the output of a function generator, in strict series with the milliammeter and an LED. The function generator is set to produce a strictly negative going signal of insufficient voltage to light the LED, but when it's in series with the 9-volt battery, what part of this do you not understand? What part of this could possibly be faked? What part of this does not apply to the discussion of current passing through a function generator that we have been having? The voltage from the battery adds to the voltage from the function generator. Current flows through the entire system according to Ohm's law and Kirchhoff's circuit rules. Alright? Thank you for watching.